Hello viewers, in today's session we are going to discuss another important problem from greatest integer function, and here we are going to find out all the values of x for which this function f of x that is given by the greatest integer of 2 over pi cos inverse 2x is discontinuous, right? So here we have to find out all the values of x for which this function f of x is discontinuous. So in order to find out the values of x for which this function is discontinuous, we are going to use two important concepts. The first concept is that the greatest integer function is discontinuous at integer points, and the second concept is that the principal value branch of cos inverse function is from 0 to pi, right? So let us apply these two concepts to get the required values of x for which this greatest integer function is discontinuous. So now let us consider this expression which is inside the greatest integer function symbol as p. We can also take it as p of x, but for simplicity we'll take this expression, that is 2 over pi cos inverse 2x as p, so that our function f of x, it assumes the form that is a greatest integer of p, right? So now this function is discontinuous for all values of x for which this p, it belongs to the set of integers, right? So whenever p is an integer, then f of x is discontinuous. So it implies that whenever this quantity, that is 2 over pi cos inverse 2x, it belongs to the set of integers, that is 2 over pi cos inverse 2x belongs to the set of integers, then this function f of x is discontinuous. So we have to search for all values of x which makes a p, or this expression 2 over pi cos inverse 2x, an integer, right? So here let us apply the concept of principal value branch of cos inverse 2x. Now we know that cos inverse theta, it belongs to the interval that is closed interval 0 to pi for all values of theta belonging to minus 1 to 1, that is theta is greater than or equal to minus 1 but less than or equal to 1. So cos inverse theta has the range, that is the interval closed interval 0 to pi whenever theta belongs to this interval, that is the closed interval minus 1 to 1. So here now we'll use this inequality to get the values of x. So now if we compare cos inverse theta with cos inverse 2x, then the value of theta is 2x, right? So cos inverse 2x, it belongs to the interval 0 to pi whenever 2x belongs to the interval that is minus 1 to 1, that is 2x is greater than or equal to minus 1 but less than or equal to 1. So now if we divide throughout by 2, then we have minus half, then we have x, and here we have half. So this implies that x should belong to the interval minus half to half, right? So now from here we have cos inverse theta belonging to 0 to pi. So we can now write cos inverse theta is greater than or equal to 0 but less than or equal to pi. So theta is 2x. So we have now cos inverse 2x is cos inverse 2x is greater than or equal to 0 but less than or equal to pi. So now here we have 2 over pi, that is the coefficient of cos inverse 2x is 2 over pi. So let us multiply this inequality throughout by 2 over pi, and 2 over pi is a positive number. So here we have 0, that is 2 over pi times 0. Here we have 2 over pi cos inverse 2x, and here we have 2 over pi times pi. So here we have 0, here we have this expression is p, and here we have 2, right? So whenever p is greater than or equal to 0 but less than or equal to 2, then we have this expression, that is cos inverse theta is greater than or equal to 0 but less than or equal to pi, right? Now from this inequality we can see that here we have 0, here we have 1, and here we have 2, right? So here we have 3 integers, that is p can be equal to 0, p can be equal to 1, and p can be equal to 2. So now here p can take 3 integer values, that is 0, p is equal to 1, and p is equal to 2, and these integers, that is 0, 1, 2 belongs to the set of integers, right? So let us now solve these 3 equations to get the value of x. So let us take p is equal to 0. So when p is equal to 0, p is 2 over pi, and here we have cos inverse 2x, that is equal to 0. So now from here we have cos inverse 2x is equal to 0 times pi over 2, that is 0. So 2x can be written as cos 0. So we have now 2x is equal to cosine 0 is equal to 1. So x is equal to half, right? And when we take this value, that is p is equal to 1, then we have p as 2 over pi cos inverse 2x is equal to 1. So from here we have cos inverse 2x is equal to pi over 2, that is 2x is equal to cos pi over 2, and cos pi over 2, that is cos 90, is 0. So from here we have 2x is equal to 0, that is x is equal to 0, right? So this is the second value of x. Now we have the third equation as p is equal to 2. So from here we can now substitute the value of p. So 2 over pi cos inverse 2x is equal to 2. So cos inverse 2x is equal to 2 times pi over 2. So here 2 and 2 get cancelled. So we have pi. Now 2x is equal to cos pi, and 2x is equal to cosine pi is minus 1. So x is minus half. So this is the third value of x, right? So by simplifying or by solving these 3 equations, p is equal to 0, we have x is equal to half. When we take p is equal to 1, x is equal to 0, and when we take p is equal to 2, x is equal to minus half. So now we have 3 values of x, that is 0, half, and minus half. So x is equal to 0, half, and minus half will make this function f of x discontinuous, right? So for these values of x, that is x is equal to 0, x is equal to half, and x is equal to minus half, this expression which is inside the greatest integer function symbol, that is 2 over pi cos inverse 2x, is an integer, right? So this expression 2 over pi cos inverse 2x, it belongs to the set of integers when x takes the value 0, half, and minus half. So this function f of x has 3 points where the function is discontinuous.